Okay, so today I'm going to be talking to you about my research and about science in general. So first of all, I'm what they call a marine geo-archeologist. Okay, so you know when they ask you what you want to be when you grow up and you say, I want to be a lawyer, I want to be a doctor, I want to be a marine geo-archeologist. How many people marked that box? Nobody? Not a single person? Well, I didn't either when I was your age because I didn't know such a thing existed. I'd never heard of it. So if you look at the word, what is marine? Do I know what marine? Yeah. I saw a hand and then I don't bite, honest. I'm more afraid of you than you are of me, promise. Yeah. Excellent. Okay, so marine is when you have something that basically relates to water. So oceans and seas, and sometimes you can even include lakes. And what is archaeologist? Excellent. Someone who studies things like vases, pottery. Okay, so an archaeologist is someone who studies the things that we leave behind. Basically, archaeologists study ancient garbage. Okay? Sometimes they're treasures, and a lot of the time they're garbage. And then there's another little word in there, geo. What do you think that comes from? There's a few things that could be geo, but what's your guess? Earth. Very nice. Geo is earth, okay? So what I am is I'm a scientist that does work in the sea and on the coastlines using geology, using earth science methods combined with archaeology, okay? So what do I learn from this? Well, first let me tell you a little bit about how I got interested in what I do, okay? And I'm going to start with telling you a little bit about my normal day. Okay, as a marine geoarchaeologist, a lot of times I'm going to ancient sites that are underwater. Okay, so this could be ancient harbors. These could actually be villages that are now underwater. And I go out and I check them out and I see what's going on there. Okay, so this is me going to investigate one of the sites that I work at. Or there's some days where I do work where I'm excavating, because archaeologists dig. So I dig as well. The only difference is I'm digging underwater, and I'm going to show you a little video of this later. But basically, this is an underwater vacuum. Because what would happen if I just took a shovel and started digging underwater? Could that work? No. What would it look like after just a couple times of digging? I wouldn't be able to see anything, right? Because it would be all cloudy and the water would get dirty. So we have a special vacuum that works underwater that we use to actually vacuum instead of dig. It's our way of digging. And lots of times I'm working with students and I'm collecting samples and I'm taking those samples and then I'm analyzing them to try to answer questions that are important to us. So first I want to take a little time machine, okay, and talk about how did I come to do what I do. So that's actually me, believe it or not, a little younger than today. And I'm somewhere, you see in the back here, there's lots of blue. Anybody want to take a guess where I am? It looks like an ocean, you're right. You can even see some boats there. Actually, I'm much closer than the ocean, believe it or not. This is actually Lake Michigan, because I am from this area, okay? I was born in Wisconsin, in Milwaukee, and we moved quite a bit around the Great Lakes, but I grew up around the Great Lakes. So I was really fascinated with boats, and I loved going to the beach and going to the lakes. How many of you have gone to Lake Michigan? Almost everybody, okay? So this is a lot of fun, isn't it? It's very interesting. But to tell you the truth, let's see, what kind of things was I into? I really liked puppies. Who likes puppies? I liked puppies a lot. I also liked sports. I was in gymnastics and swimming. Who likes sports? Nice. And I played basketball, and I played soccer, and I played all kinds of sports. And I liked art. I liked to draw. Does anyone like to draw? Awesome. And how about, anyone in a brownie troop? Do you guys still have brownies? Girl Scouts? Oh wait, you're too old for brownies. Girl Scouts. Okay, well I was in Girl Scouts and brownies and liked to go camping. And ballet, that didn't last very long, but you know, I liked it while it lasted. And I like to watch television. Who likes to watch television? So I like to watch television too. But there was one thing, or one group of things, that I actually really, really liked, and that was disasters. I know, it might sound a little bit odd, but I really liked, because I was on the Great Lakes, I would hear these stories about shipwrecks. Well, you're thinking, shipwrecks, the Great Lakes? Well, did you know that there are more shipwrecks in the Great Lakes than all of the Caribbean? Who knew that? Who knows that now? Okay, the Great Lakes are actually an incredible place for shipwreck archaeology, because even though, well, they're not very small, they're very big lakes, but when you have a storm in the Great Lakes, it can happen very fast, very quickly, and also a lot of boats are on the Great Lakes. And so over the years, there have been many, many, many shipwrecks. So this is how I got interested in archaeology and in underwater archaeology. But my disaster obsession went through this for a few years, and unfortunately I had a few teachers that would tolerate this. So I studied every disaster I could come into, and where did I get a lot of my information? And this isn't just a promo because we're coming from National Geographic. This is in fact very true. I used to go and look in the National Geographics. Okay, so this was my education outside of my education. But one shipwreck in particular I thought was just totally fascinating, and that was the Titanic. Who's heard of the Titanic? Everybody. Okay, so if you can believe it, when I was, let's see, most of you, how old is everyone here? 13. Okay, so by your age, this had already happened, but when I was getting into the Titanic hadn't been found. Okay, they didn't know where it was. I mean, they knew where it was, kind of, but they hadn't actually found it. And when I was about 11 years old, this is another time machine from 1985, the Titanic was found by Bob Ballard, and they actually took photographs of it. And for me, as a child, this was amazing. Okay, this was amazing, because if you could go and find a boat, find a ship that deep in the ocean, you know, what else is possible? So, what map is that? What's the map that I've got up there? The 7 continents. Now, this is a photograph, well, this is an image of the Earth at night. Now, do the continents glow? No. Why is it glowing? The lights. And where there are lights, what else are you going to find? People, right? People are turning on the lights. So I like this map of the Earth because it really shows us the reason that we can make out the continents is especially because where do people like to live? They live on the coastlines, okay? Most of the population on the Earth lives within a mile of a coastline. There are rivers, lakes, oceans, and so this is why when we look at the Earth at night, we're able to make out the continents because people are living all around the coastlines. Now for me, the reason that this is very important and very interesting is that coastlines aren't constant. Did you know that? Is the coastline always the same? It changes. Who knows what the state rock of Michigan is? What is the state rock? There's an official rock of Michigan. Anyone know? The stone, the official stone. I heard it, I heard someone say it or try to say it. Petoskey, awesome, very good. Well done. Now, the Petoskey stone, does anybody know what it really is? It's a fossil, okay? A fossil of what? It's fossilized coral. Where's the nearest ocean? Are we in the ocean? Why do we have fossilized coral rock as our state stone? Excellent, because this was an ocean, okay? The coastlines change. So this place that's now land, the time of those corals, it was actually an ocean, okay? So it's really important for us to understand how these changes happen because a lot of very, very, I hate to say it, but sometimes dangerous things can happen on a coastline, okay? Coastlines, if you guys remember last year, anyone hear of Hurricane Sandy? Did you watch that on the news? Okay, so this was a major hurricane that affected a lot of people. And for some people, it was, unfortunately, there were people that even died because of this hurricane. And of course, we have the issue of tsunamis. And so as people continue to live on the coastline, and we have more and more and more people living on the coastline, it's really important for us to know what happens on the coastline so that we can be prepared, right? Because if we don't know, we can't be prepared. So I work in a place that is an ancient harbor. So this is everything that's dark right here. This is the coast. And this dark stuff is actually a submerged Roman harbor. It's about 2,000 years old. And when it was built, and this is my mentor, this is the underwater archaeologist who I trained with, Avner Rabban. So he worked there for about 20 years and investigated this sunken harbor. And the question was, why is a harbor underwater? A harbor doesn't work very well if you can't use it. Okay, if it's underwater, there's a problem. And so we wanted to solve the question, why did this harbor sink? So this is to give you a picture of what it might have looked like when it was actually working, when it was actually a functioning harbor. So how did they build this thing? This is an amazing, amazing structure. They actually built big wooden boxes, and they would tow them out to where they wanted them, and then they would fill it with cement. And it would be in layers. The lowest layer would be of one quality, and then the middle that nobody ever sees, they would sort of throw in lots of garbage, and there'd be big pieces, and the quality wouldn't be as good. And then they would put in another layer. So it would sort of look like if you took the wood away, it would look almost like a layered cake. So here's an example from our work of some of the samples from that concrete. Now, we do a lot of work there making special maps. And this is a special map that actually measures how magnetic the area is. And we did this because we wanted to understand the harbor better. But what was strange is that offshore, there were these weird spots that didn't connect to anything that we knew. So we decided to go ahead and excavate there. This is just to show you, I showed you a picture of us excavating, but this is sort of a film of how it works. That's a plate that's about 1,600 years old, okay, over 1,000 years old. And when we use this vacuum, we're able to take up the small material, which we've already sampled a bit of, and then we're able to work very carefully around the objects. So that's how we actually do the excavating. So what did we find? What we found there were a few things that gave us our strong signal. And one of them, these rocks up here are actually quite special. What they are is what we call ship ballast. You want to know what ship ballast is? What would happen was the merchants would come, the ancient merchants would bring their ships with all their goods, and they would take it off the ship. But now as the ship's lighter, and sometimes it was too light, and so they would load stones onto the ship in order to balance the weight out, and that's what we call ballast. And we can take these stones that we collect at the place in the harbor, and we can reconstruct where all the ships came from. Because if they took stones from a place far away, and the stones were like a Petoskey stone, okay, if we find some Petoskey stone in our harbor, where did the ship come from? Where would it come from? Michigan, okay? So if we found Petoskey ballast, we could say, okay, well, this ship must have come from Michigan. So we found all kinds of ballast and ceramics and other pieces of stones and little objects. But what was really strange is we kept excavating, and suddenly, this is me looking very surprised, we excavated through a very thick layer of shell. Now, you might be looking at me going, gee, you're underwater, you're in the sea, and you found shell. That's thrilling. Well, it doesn't sound that exciting, but let me tell you a little more about this shell. The shell is a type of mollusk that only lives in very, very deep water. And we were working in about 30 feet, but these are shells that like to live in over 150 feet. So what does that mean? If we found shell that's normally in 150 feet, and we're finding it in 30 feet, what must have happened? How did it get there? Good question. Okay, so we had to think, how did this shell get there? And it turns out, once we sent these samples in and we did some dating. We sent it in what we call radiocarbon dating, which is a method where you can analyze the shell and know how old it is. And when the age came back, it was about 1900 years old. Okay, when the harbor was about 100 years old. And we looked into the historical record, and guess what somebody wrote? In 1:15, on December 13th, 1:15, at 11:11 p.m., a large wave came and destroyed Caesarea. Have you ever heard of large waves coming and destroying places? What do we call that? Tsunami. So this was the first example we had of a tsunami deposit. Then we started to think, oh my goodness, how did we miss this? We've been working in this harbor for 20, 30 years. What's wrong with us? So we started to go back and look at other places where we'd worked in the harbor. And sure enough, we realized we have these towers that are outside the harbor. And we noticed that they were on their sides, and we never understood why. And we know that they went on their sides sometime around 1:15. We also noticed other areas that we had excavated where we had made these little diagrams and we'd written, we've got a destruction layer. We didn't know what it was, but we knew it looked like a destruction layer. The other thing we looked at is the sand. Now, why would I care what is sand? First of all, think in your minds, just think in your minds when I say the word sand. I'm going to give you a short little geology, little geo-sedimentology lesson. How did you know that? That's excellent. The answer was sand is little rocks, and actually that is very correct. Sand, the technical term, means a certain size of rock. Okay, very good. Certain size of rock. So we look in the sand, but what the sand is made out of can be a lot of different things. And in the case of Caesarea, we have, this is what the sand looks like when you look up close. You guys see those tiny little things that look like little shells? They're less than the size of a grain of sand. They're very, very, very small. But they're very important and they're very useful. We call them foraminifera. And the reason that they're so useful is because they are very picky about where they live. And so when we look at the sand in the tsunami layer, we look to see, do we have any of these foraminifera that are far from home? Okay, has anybody been moved from where they're supposed to be? And sure enough, they were. Now, in science, one of the things that we do is, even when we have the answer to a question, we're usually not satisfied, okay? Because in science, we're spending a lot of time disproving things, okay? Scientists want to find answers, but even when we find an answer, we always need to make sure to eliminate all the other possibilities. Okay, one thing about the scientific method is that we're actually spending our time disproving things. We're not really proving anything. We want to disprove all the options so that what we think is the answer is supported. So I'm going to show you now, after we found the tsunami deposit, we wanted to go and see, okay, if it's a tsunami deposit, then we should see certain things with it. We should see certain features. Now this video, whoops. Let's try that again. Now, one of the most exciting things in my work
concrete mixture was poured
is that sometimes National Geographic will come and film the research. And this was one of those times.
Once it was in position, then all of the superstructures, all of the platforms were put on top of it to actually build up the breakwater to be a functional surface.
So the harbor is really an architectural marvel.
But it's an architectural marvel with a grand riddle attached. What destroyed it?
Today, what you will see in the harbor is a massive rubble field throughout the inside of the harbor, which was always quite curious, where this rubble field came from.
Outside the harbor, scientists discovered something strange. The breakwaters had not been pushed in by the battering Mediterranean, but pulled out toward the sea.
Those are the towers I was telling you about. Those big blocks that you see, those are the towers.
excavation of those towers, it was noticed that the towers were undersized.
A hugely powerful force had turned the tower bases and pushed the breakwaters away from land. Beverly Goodman and her colleagues set out to track down the monster. To do it, they've developed a new risky technique for taking a core sample from the ocean floor.
To collect cores from the seafloor, we set a base that secures a pipe. So the pipe goes into the middle of the base. And then on top of the pipe is a hammer. Once the pipe is in the seafloor, then you have to remove the pipe.
To do that, they attach a parachute and fill it with air. Now, Goodman opens the core. In 13 samples, she's seen the same startling results. The core is a cross-section of what the seafloor looked like over the last 2,000 years.
Sometimes you get very lucky. This is pretty much as good as it gets. We're getting exactly the sequence that we've been seeing.
The sand at the bottom lay on the seabed about the same time Caesarea was built, around 20 BC. Above that sand, later in time, is the fingerprint of a catastrophe. This is a mixture of seashells and a piece of ceramic. 2 layers of it exist all around Caesarea's harbor. How did shells and pottery get mixed together and dumped into the sea? The best answer is a tsunami. Underwater earthquakes cause most tsunamis. Tectonic plates collide under the ocean floor, displacing mountains of water and breeding a killer wave. The powerful waves dug beneath the breakwater foundation, then breached the walls to ravage Caesarea. When they roared back to the sea, the waters carried the detritus of the battered city and helped tip the breakwaters over backwards. And they left their calling card, layers of shell and city debris.
The tsunamis probably were one of the biggest factors in the ultimate destruction of the harbor.
Radiocarbon dating and historical records suggest the first deposit was left by a...
Okay, so that's how we do the work, all right? So there's a lot of work that we do in the field, a lot of work underwater, and then there's a lot of work, a lot of analysis in the lab. So when we went out and collected those cores, we collected a whole bunch of cores. Here's a map, all those dots are where the cores are. And then we opened the cores and we looked for these layers. And here's some close-ups of some of the things that we see in the tsunami layers. And we're analyzing all this material to try and find signs of the tsunami. Now I put this slide up because how many people here have had their teacher say, you have to show your work? Anyone have that written on their thing? That's great that you got to the right answer, but you better show your work. Well, we have to show our work all the time. So I'm just showing you one example of me showing my work. Okay, so each of these columns is a different type of analysis. And I'm showing how the tsunami deposit looks different than the other deposits. So this is my showing my work, one example. So every single core has at least 3 or 4 diagrams like this for me to show my work. And then you take all of those show your work, and when you put them together, we actually found a picture where you have these bands, those are not just one event, but after we went out and collected the cores, we actually found 3 events. And since then, we've actually found 2 more. But anyway, at this point, we found 3 tsunami events that hit Caesarea. And one of them is even as old as Santorini. Has anyone ever heard of Santorini? The eruption of Santorini? Well, this was a major volcanic eruption in the Mediterranean, and it seems to have also affected Caesarea. So this is really important. Why is it important? Well, I told you that people live on the coastline and people build on the coastline. So see in the background here, these big, big, big stacks? That's a power station. What happens if there's a tsunami? Uh-oh, right? We're gonna have a problem with power. We're gonna have all kinds of things. So understanding these past events is a way that we can know where tsunamis have happened. where these events have happened and where we should be very careful about building delicate things. So my team, we've also gone to other parts of the world. We went to Crete, which is over here. Here's where Caesarea is. Does anyone know this is where Israel is? And Caesarea is on this side. And we went to where this star is, which is a place called Crete. And there we also found one of the events that we see in Caesarea, we found there. And when we're working, sometimes when I'm working, I don't have all of my gear. Okay, sometimes we get an emergency call, quick, come, we've got a permit, you can work, get over here as soon as you can, and I'm not able to bring all of my people and all of my equipment, and so sometimes the work looks a little bit more like this. A little bit sad, huh? But we find every possible way to get our work done. Has anyone ever helped put in a fence post? Well, this is how you put in a fence post, and you can come and help me out if you know how to do that. But this is one other way that we collect the cores. And so we're also going to the coastlines, because coastlines all over the world, I'm sure you guys have heard about the fact that there's warming happening all around the planet. Well, one of the things that happens with global warming is that the sea level is rising. Okay, so our coastlines are kind of getting smaller and smaller, and we're getting some erosion. So this is another thing that's very important to us and that we're looking at on the coastlines. Some of the other work, I work in an area called the Red Sea. And in the Red Sea, we went there to do an environmental study on the coastlines, and oh no, what happened? Turns out, in this place that has no tsunami history whatsoever, we found a major tsunami. So this is an area where 200,000 people live on the coastline, and they're very dependent on tourism, and it's a it's growing very quickly. And it turns out that it isn't a tsunami-free zone, that there was actually a tsunami in about 300 BC, and it was a very large one. So by doing this work, we're helping them know what they need to be concerned about and to be able to prepare for the future. Now, usually when I talk, I'll talk about tsunamis and I'll talk about all these things, and I always get the question, do you see sharks? Was anyone thinking about sharks as they're watching the footage? Be honest, yeah. So I will tell you one quick shark story, okay? How are we on time? Are we 20 minutes left? Okay, great, we have time. Okay, the truth is, sharks are very shy. Sharks don't really like to be around people if they can avoid it, if they're not being fed by them. So I haven't seen a lot of sharks, even with the thousands of dives that I've done. However, one time when we were doing, this is me, and this is one of my partners, Timur, we were working at about 145 feet. Okay, so this is pretty deep. And when you're working that deep, you can't actually, if something happens, you can't swim to the surface as fast as you can, okay? You have to take your time coming up because otherwise you can get hurt, okay? This is called decompression sickness. And so whenever we dive, we take a long time, we take many stops on our way up. So if something happens, you can't just rush to the surface. You can't say, just get me out of here. You have to stay where you are. Well, we were working, and when you're working with a buddy, you check in on them and, you know, are you okay? I'm okay. Everyone checks on each other. So we were packing up the gear, and I looked up to see how Timur was doing, and behind him, what did I see? I saw a minibus. But I knew there couldn't be a minibus underwater, right? It was so big that it looked like a paper cutout of a massive minibus just being dragged behind him. And I didn't know what to do. So I thought, okay, I can't rush to the surface. I don't know if that would even help me. I don't know what to do, and we haven't finished our work here. This is the other problem with scientists. We're a little bit, you know, we're so focused sometimes on our work that, of course, the thought was, I have to finish the job. So I looked at my dive buddy, I looked at Timur, and I remembered, oh yeah, there's a sign for shark, there's a sign for shark. So I, you know, kind of got his attention. I was trying to act really cool, my heart's going like this. And I, you know, he saw, and I pointed, behind, you know, pointed, and I went like this. Okay, this is the sign for shark. Yeah, but I was trying to act really cool and relaxed, you know. Yeah, shark. And he doesn't understand, and he's looking at me, shaking his head, you know, what are you talking about? And you know, I tried again and still nothing. But of course I'm watching the shark, and the shark is going off, and it's going off into the blue, and I thought, okay, let's just finish. We don't have a choice anyway. We can't go running anywhere. We'll finish the work and we'll go up. So of course the whole end of the dive, every time something bumped into me or I bumped into something, I would, you know, jump, and it was a bit scary. So we finally come up. We've got about another 45 minutes, hour until we're on the ship. And I explained to Timur what happened. I said, you wouldn't believe it. There was this huge 16, 20-foot shark behind you. And it was a tiger shark, which is, you know, they can be very large. And he goes, oh my gosh. I could not figure out for the life of me why you were giving me the sign of the rooster. So we didn't have a photograph of it, but fortunately Timur did a quick SketchUp of our encounter with the rooster. So now every year when we bring our students to train them, we do a long practice session of how to do the sign of the tiger shark versus the tiger rooster. So I just want to sum up so we have some time to talk, and I'd love to hear your questions. You know, basically, I want to share that there's a lot of things that we can learn, lots of things that we don't know, and we need to look at the coastlines and understand what the past history is, because this is how we're going to make the world an even safer place, and we'll be able to for many, many, many years, enjoy all of our coastlines. Thank you.